We're back to the course, the SQL database with Java. What you should know at the end. Be ready and let's go. Well, we're going to install the software that we'll be using in the next couple lessons to learn SQL. We'll install the SQLite command line shell in our computers. And we're going to have an overview of the terminologies that are used in database development. What you should know at the end is how to install SQLite command shell on your operating system, on your Windows, Mac or Linux. Second, the technical terminologies of databases. Here we want you to know what databases are: table, column, row, and view. There are more terminologies, but these are the most important that you need to know. This is the end of the class. Please revise if you need to know something. Let's move to the next lesson. We're back to the course. Be ready and let's go. Well, we already know that SQLite is a database tool. Let me tell you that the SQLite command shell that we're going to install is where we'll work at the beginning. Why we're going to use the SQLite command shell to write or work at the beginning as SQL database developers? Well, it's much better to get this approach before you move into code so that you can really understand how to use SQL and SQLite before you mix with any other programming language. That's why we're going to use the command shell first. In SQLite command shell, we'll create our database and work with data. Then we'll move into database creation with Java. Creating database straight away is not helpful way to learn SQL, SQLite and Java at the same time. When you get error, you need to check if the error is in your code or in the SQL statement that you've written. When you learn SQL, you're preparing yourself to communicate with the database and use relational database management systems like SQLite, MySQL, PostgreSQL, Oracle, and more. This is the end of the class. Revise and let's move on. Install and setup of SQLite for Windows and operating system is what we're going to do today. So be ready and let's go. Well, it's time to install the SQL command shell. For the Windows operating system, the SQL command shell is just an executable file called SQLite3.exe. Exe is the extension of executable file. So how do we get the bundle that we want right now to run the SQL command line shell? Let's come here to our browser. In my case, I'm using Google Chrome. It doesn't really matter what browser you are using. What really matters is that we follow the same steps and we go to the same page in order to get what we desire. Let's write SQLite here, hit enter. The site is www.sqlite.org, SQLite homepage. Let's get here. The first thing that you are going to see is what is SQLite. If you want, you can read. We have a top menu here with a blue background and white color on the options. We have home, about, documentation, download, license, support, and purchase options. Oh, I had forgotten. We also have search option. We're going to get here on the download because we want to download the file. Here we have several options for downloads. Precompiled binaries for Linux, for Mac OS, we want for Windows. Why Windows? Because now we're talking about Windows and I'm using a Windows machine. If you're using another machine, so skip this video and go to the video where the operating system of your machine is being used to install the SQLite. We're going to install this one. In the description, we have a bundle of command line tools for managing SQLite database files, including until right this point where we have programs. Let's click here. It's a small file. Okay, it has already been downloaded. Let's go to where it is. Here we have. I had downloaded and I've downloaded it again. So let me delete one. Cool. What we have to do right now is to extract this downloaded file. So let's come here, extract all. Here we have. Let's take this, open, and the 3 files are all here. Copy this folder that contains the three files, find a place in our computer to paste this folder anywhere, even here. But I want to organize this program. In my case, I'm going to store here where the disk is P, that stands for programs, program files, Control V. The next step is to add the environment variables in our computer to support SQLite. Let's open here our folder and copy the path where the files are. You can just click here on this area, Ctrl A to select all and copy. You can even write Ctrl C. Now it's time to look where our environment variables are. Let's come here to this PC or my computer and give a right click, go to the properties. In properties, we have to get to the point where we find advanced system settings. The left menu has this option in this right here, advanced system settings. Here we have several menus. Come here to advanced and click on environment variables. Open here. When you are in this part of environment variables, you shouldn't play too much or make any change without knowing the effect of that change, because variables of systems or even users can damage your computer. Let's focus really well on what we want to do. Come here to user variables. The variable is path. If you don't have all these variables or any of these variables in your user variables, don't worry. All you need to do is add a new variable, give it the name of path, and the value you have to paste the link of the file that we have copied. But what I'm going to do is come here into the path variable. You may also have the path variable in your computer. Click on edit, and here we have the variable names that are already in our computer. Cool. How we want to add a new variable? What we have to do is to add a semicolon and paste that path. Finally, click on OK to this point, and we have already updated our environment variables. Only that. In Windows 10, we have a different way to add the environment variables, but the essence is the same. So let's just click OK and OK again. I'm going to click Windows D to hide all. And now let's go to the command prompt to test if our SQLite3 command shell is already installed. I come here to the bottom left corner, give a right click and open the command prompt. What are we going to write now is SQLite3. Hit enter. We have SQLite version 3.36.0 and the day. Well, if we have this message, that means our SQLite is already working. This is a good news for us. If you don't have, that means the installation has failed in your computer. So revise how I've done so far and follow every single step. If you don't have the same version as I do right here, it doesn't really matter. How we don't want to work right now, this lesson was just to install the SQLite in our computer. We're going to quit and exit our command prompt. So let's just write that quit. Okay, I've already quitted. This is a command that we are using right now from SQLite, but later on we're going to talk about more of that. So let's now exit, and that's it. This is the end of our class. Revise if you need to see something. In this video we're going to install and set up the SQLite for Mac operating system. So if you're using Windows, please look for the Windows video. If you're using Linux, look for the Linux video, and this one is specifically for those who are users of Mac OS. I'm not a user of Mac OS, I'm using Windows, but I'm going to show you how to install. Be ready and let's move. I have a great news for you. The SQLite comes pre-installed on your operating system. All you have to do right now is go to your terminal, what we call in Windows command prompt. For you in Mac OS is terminal. Go to the terminal and write SQLite3, hit enter. You're going to see the version of the SQLite installed on your machine, and you just have to use the service instead of installing. If your computer is a Mac and it doesn't have it already installed, it's possible to install, but most part of the Macs have it pre-installed. I have here a post where you can see how to install SQLite on Mac. I won't be showing you because I don't have a Mac here. As you can see, it comes pre-installed on Mac, so you simply open the terminal application and type SQLite3 to launch the server. If SQLite is not automatically loaded for you on Mac OS X in order to install SQLite Mac, the first step is to download the SQLite zip file. You can download from this website here, unzip the file where you're going to extract the archive and move the extracted folder into a convenient location. The third step is to start the SQLite server. Right click on SQLite3 file and click open. This will allow you to execute a file from untrusted developer. That's it. But before you try this way, please make sure that you already have or not the SQLite3 installed on your Mac. I think that you're going to have it already installed. So this is the end of our class. Please revise if you need. And let's move to the next lesson where we're going to talk about the Linux users. Install and setup of SQLite for Linux operating system. I'm not using Linux. I'm going to show you how to install. Be ready and let's go. Simple commands that you need to write in your terminal. First, just write SQLite3. If it is not installed, you're going to have an error message saying that SQLite is not installed. Then write the next command, sudo apt install SQLite3. Hit enter. Then you're going to insert your password if your computer has one in your terminal, and it will install automatically for you. Next, you have to write again SQLite3 just to test if the SQLite was successfully installed. You're going to have a success message where you're going to have the version of the SQLite installed. The version doesn't need to be the same that I had when I was teaching how to install on Windows or in any other tutorial that you're going to see. Then you have to write that quit to close the SQLite command shell and exit to close your terminal. If it doesn't seem to be enough for you, I'm going to use another resource to help you. The first thing that you have to do is to update the apt repository cache. So you are going to be following these steps if you didn't have the installation succeed in the previous steps. The first thing that you write in your console is sudo apt update. Hit enter. The next is sudo apt upgrade. Hit enter. Third, sudo apt install SQLite3. Hit enter. Finally, you write SQLite3 -- version, and you're going to have the version of your SQLite. This is the end of our class. We're back, the SQL database with Java. Be ready and let's go. Before we start talking about the terminologies of databases, I want to tell you that terminologies are important in any area, whether the area is scientific or not. Important because they facilitate the understanding of a certain problem or explanation related to that subject. In our case, we're going to see terminologies of databases, and they will often be used during this course and during your career as a developer, whether for SQL databases or not, but as developer and in this course, they will be important. Terminologies are going to allow us to understand our application easily. First one is database. Database is simply a collection of organized data. It's the container of all the stored data. Imagine the posts, the uploads of videos, of stories, musics that you make in Facebook, for example. All that data needs to be stored somewhere. Where it is in the database. Facebook servers have a database to contain all our data. So the Facebook database is the container of all our stored data. The posts, the comments, the likes, and whatever you do that is stored on their site. When you say database, you include all data stored in the queries and the structures also. Database dictionary is simply a list of the structure and data types in your database. When you say database dictionary, I want you to imagine them as tables and fields that reside in your database. The collection of the names, the definitions, and the attributes about the data that you're going to store on your database. Next one is a table. You've seen a table in your life, that beautiful intersection of horizontal and vertical lines. Table is a collection of related data held in the database, collection of rows. SQLite or SQL database in general is a good database to store structured data. Structured data is that type of data that you know which structure is going to follow. For example, I want to store details of a bank account of a customer. I know that I'm going to have a structure where I'm going to store a name, its card number, the card type or the account type, the amount of money that he has on his bank account. Cool. If you want to work with data that's unstructured, like in big data, a SQL type database is not good or is not ideal for storing that type of data, but that data can be stored in a SQL type database. The most ideal database to store the type of not structured data is a NoSQL database. For example, you can use a MongoDB database, which is NoSQL and is widely used among scientists to store data related to big data field. I have here in front of me two tables. One is related to the clients and other is related to the orders. In the clients, I have how many columns I have. 1, 2, 3 columns, the name, address, and the phone number. We have values in those columns, which are Alexandra Peter, Florida, 5677805 for the Alexandra Peter record. We have orders here with description. For example, the first one was made on 2021 7/18. It's an 825 gigabytes PlayStation 5, purchased paying $690.99. Another order is here, 13-inch M1 Mac, $1,200. I want this one. I hope I will have this one. Let's move on. I want you to see column, fields, or attributes as the same, because they are often used interchangeably to mean the same. A column is the smallest unit of storage in a relational database. When you talk about a column, a field, or an attribute, idealize them as variables. Variables have a data type and a name. Every column has a name and a data type. The type is to determine which data type gets into that column in our database. We have, for example, right here, the column of date, description, amount, and order. Let's focus on the date, description, and amount. For example, we have different values there. Description, what data type is there? It's a string. 825 gigabytes PlayStation 5 is a string. That's the data type. Amount, some databases can store them as real, doubles, integers, or number in a broader way. The data type of the amount column is number, description, string, date. Some people store dates in strings, some databases support date as a data type, so we're going to say date column has a data type of date, order, number, or string. It's going to depend on how you're going to store. Row or record. A row is a collection of column values. A row is all the column values that you're going to find on a row, as its name says. For example, here I have one row or a record. This row has values that correspond to columns. This one is the order value, the date value, the microphone, and the amount value. So when we talk about the record, we are referring to all this data at ounce, the collection of column values. Our order table has 5 rows, and our order table has how many columns? 4 columns, which are they? The order column, the date, the description, and the amount column. Query. We're going to write queries as we progress in this course. Queries are just simple comments or complex comments to retrieve data from the database. It won't be meaningful if you just store something in your database and you can't retrieve that. So that's why queries exist, to let us retrieve data from the database. Look at this table of orders in your screen. We have all the information here. The name of the person who made the order. The first one was Alexandra Peter. Address of Alexandra Peter is Florida. The phone number is 5677804. The amount that he paid for the 825 gigabytes PlayStation 5 is $690.99. It was on 18/7/2021, and it was the first order. Cool. We have all the names. This table can be split into 2 tables. Let's see. I can just have the table of the clients and the orders. Look at this. From the name, address, and the number, phone number, I can have the client's table because this info is related only to the client, and then I can have the orders table. Here, the name column of the client's table is related to the name column of the orders table. The name column of this client's table is related to the name column of this orders table, and in relational databases this is called a join. Let's see one advantage that we have here. Imagine that you want to update the Henry Quick's address from London to Glasgow. Let's first go to the previous database where we had only that table, one table. If we want to update Henry Quick's address, what we're going to do? Well, before we update, we have to know that Henry Quick can do many orders. It's possible to have one person making more than 1,000 orders. It's possible. And what we would have to do in this case? Well, we would have to go through all our entire table and see where the name is Henry Quick, change address to Glasgow. If somebody has many orders, that can be an intensive work because we will have to update many rows. But in this case, we can simply focus on updating the address one time because this data is only related to Henry Quick. This is the client, and we only store one time the address. Then if we want to have records related to Henry Quick in our orders, we simply relate to the name, and the address is nothing that needs to be repeated many times, since it only appears one time in our records. So here we have less intensive work in our database. The same would be applied to the phone number. This type of relationship is one-to-many. Why one-to-many? Because we can have one name here, Henry Quick, making many orders. As we can see, we have Henry Quick here buying a 13-inch M1 Mac, and now we have him with a smartphone. So that's the idea. We have this third design where we have a link table here called clients orders. It's often used a link table to link data between two tables. In this case, we're linking the data between clients and orders. In this implementation, what happens when a new record in the orders table is stored, a new record in the client's order table is also stored to link the order with the customer name. Simply. For example, here we have order 0002 and the name Harry Quick. We know that Harry Quick in our clients corresponds to this row. His address and phone number is this one, and the details of the order are here. The biggest advantage that we have in this implementation is that the tables only stay with data related to their purpose. In orders, we only have orders data. In clients, we only have clients data. That differs from this implementation where in orders we also have name. This is called database normalization. It's a simple way to organize data in your database in such a way that you remove redundant, irrelevant, and duplicate data in your database. The more you make the normalization of your database, the better your database has been structured. What a view is an alternative way to present data on a table. It's the selection of rows and columns from more than one table. For example, we have clients orders view. All we want in this view is to have the order, the date, the description, the name, and the address. We've selected the columns that we want from two tables, the clients and the orders. That's what we've done here. This is the end of the class, but before we do so, I want you to take important notes. In SQLite, the entire database is going to be stored in a single file, while many other databases store in multiple files. And in SQLite, you're going to be using the SQL language. Hello, this is the SQL Database with Java course. In this lecture, I want to bring to you some useful tips for this course. The number one tip is to join Discord server, Facebook group, and GitHub. Next, watch all the back to the SQL Database with Java course from the Tech Skills. In this section, we're going to see the basics of SQLite. We're going to get an overview of what the section is going to be. Without further ado, let me present you what it's going to be. First, our main idea is to create basics databases and tables and manipulate them. This is our core idea. Next, I'm going to tell you what you should know at the end of this section, and we're going to teach you how to do it. The first is how to create a database, a table, insert data into a table, and retrieve data. When we insert data, we insert for a specific purpose, and when we retrieve, we want to use the information for something. A database is complete when we know how to insert a data, how to retrieve, how to make operations like deletions, updates. Next, we're going to see how to make a backup of a database and restore a database. It's important to know how to make a backup of a database because before you make a certain harmful operation or work with your database, it's necessary to have another version of the database so that if you make something wrong with the current database in which you are working, you have how to restore. Next, how to update all and specific records of a field. When we insert data, we save the data, but at a certain moment we may want to change its content. That's why we have the update. But also we may want to delete the records from our database. We're going to see how to delete all and specific records of a field. You're going to get the concept of a field as long as we progress in this course. Next, we're going to see how to use common SQLite commands such as the tables, the dump, and schema. If you feel lost during the course, put your questions in the Q&A section. That will help me and your colleagues to help you. With that said, all I want you to do now is be ready and let's go. Start with this section and learn something new. This is the end of this class. Revise all the concepts if you need, and let's move to the next part. We're back. This is a new section, Basics of SQLite. Now that we've set up our software tools and we have already learned about the terminologies of databases, it's time to start creating some databases. So be ready and let's go. The first thing that we have to do is open our terminal or our command prompt. It doesn't really matter what name you have as long as you open your terminal in your machine. In my case, it's window and is command prompt. I'm going to maximize it and put it on the center. Here I have on the center. Let me put in the full resized mode. Okay. The first thing that we're going to do inside of our command prompt, the program responsible for interpreting every command that we are going to write here, is going to be SQLite3. Just to start the SQLite program, hit enter. Cool. Now I have here a message that states enter that help for usage hints. Usage hints are just a help, as the command says, that really shows you a command available in SQLite3 and the definition. That's right, that help rather than talk and see. We have all these commands available for our usage. Don't worry if you think that you have to memorize all of them. You're going to know them as long as you practice or you create databases and you use them. So you're going to learn them when you need them. I've showed you where to get the definition of a SQLite command. Now it's time to quit this SQLite program. To quit, we just write that quit, and what this does is this simply executes the command first, that quit, and exits this program. Which program? The SQLite itself, not the terminal or the command prompt as a whole. Now we're executing SQLite3 as you can see here. So let's exit this program. That quit. Here we have. Now I want you to create a database. Our database is going to be responsible for storing contacts of our friends. Our database is going to have a name, and the name of our database in our case is going to be friends. So let's start creating SQLite, writing the command SQLite3 space friends.db. Hit enter. Cool. Now we've created the friends database. In friends, we're going to create a table, and this table is going to have the name of contacts. This table is going to be responsible for storing information about our friends contacts. To create tables and retrieve data, we use SQL commands. We have SQLite that implements SQL, and we have SQL as a whole language. We use SQL language, and SQL commands end with a semicolon. It's like a Java statement or a command. They end with semicolons. The first statement that we're going to see from SQLite is to recreate our table. And what is the statement? Well, it's create space table space the table name, which is going to be contacts. We'll open a left parenthesis. We first write the attribute or the column or the field that we want to store, in our case a name, and then the data type, which is a text, comma. The next field is going to be the phone, which is an integer. Finally, we're going to have the address, and the address is the text. Close the parenthesis, use a semicolon, and hit enter. Let's hit enter. Here we have. We don't have any response here. What that means, in form of text, being more specific, that means that the statement was successfully executed. If we had an error, we would see, well, we've created our table. How we've created our table? We want to insert data inside. And how do we do that insertion? Well, we have SQL commands responsible for doing that insertion for us. It's often seen that people in the development environment use uppercase letters to write SQL related commands, and they use non-uppercase letters to write commands that are not related to SQL. Well, SQL in its own roots doesn't consider if you write an uppercase letter in a command or not. But in this video, we're going to use the uppercase letters just to write the commands that are going to be related to SQL itself. Now we want to insert. How do? We write insert into space into somewhere, and now is into the table that we want to insert, contacts. Let's open the parentheses and pass the fields that exist in our table. We have the name, we have the phone, and we have the address. Close the parentheses, space, and the values that we want to store there. Open parentheses. We can use single or double quotes. When we work with Java, we usually use double quotes, and how we're going to be using double quotes from Java, we can now use single quotes here, or even double quotes. It's your preference. Let's use in double quotes. How is a preference? The name can be Jonas. Yes, Jonas or Jonathan, comma. The next is the phone. The phone is going to be this one. Next, the address. He lives in London. Double quotes, London. Let's close with a semicolon and hit enter. We don't have any warning, so it's fine from now. It's time to use queries because we want to get data from our database. I told that we would be writing queries in this course, so it's time to start writing queries. Well, we want to get the data from our database. How do? You write select asterisk, that means all the columns from space the table, which is contacts. Hit enter. You can see that our SQLite program is waiting for something. It didn't execute that query select from contacts. Why? Because we're missing a semicolon, so it's time to add it. If you didn't add before, you can add right now. Hit enter and we have Jonathan, which is the name, the 54832 is the phone number, and we have the address. Well, if we have so much data, we may not know how to identify for which column each data is. So let's start on the headers. That headers on, and let's query again. Select all from contacts. Hit enter. Now it's time to add the semicolon because I have forgotten. Here we have. Now we have the headers. We can see that the first column is related to the name, the second is the phone, and finally we have the address. Cool until this point. You know how to create a database, create a table, insert data into your table, and retrieve all the data from the table. I want you to know another way to insert data into database. Let's come up here and write insert into the table name, contacts. Open parentheses. Let's now specify the parameters. But before I teach you this way, I'm going to show a more interesting way of doing the same. Without specifying the parameters, we can simply say values. And here we pass all the values that our table contacts supports in the same order. First is going to be the name, Mark. Next is going to be the phone number. Here we have. Finally, the address, California. With that, let's query select everything. That is the meaning of asterisk from contacts. Here we have the data being retrieved from our DB. Let's simply try to insert two values. The next person is going to be Maria, and only two values. Let's see the enter. We have a name. Our table contacts has 4 columns, but 2 values were supplied. So if we want to add, we have to pass all the values using this way of insertion. But that's not the end of the world if we just have 2 values or values that are less than the total possible in our table. Let's right now insert Maria and 6773 only. How can we achieve that? We simply write insert into the table name is the same, but now we have to pass specifically the fields. We want to insert into the field and the phone. Now what are the values? The values are Maria and 6773. Let's see if it's going to accept or not. Success. Let's now query everything. I can write in my console the previous written comments using the up arrow key, so I'm going to use this for my advantage. You simply have to write select asterisk from contacts, and let's see if we have Maria now. Okay, here we have Maria doesn't have an address, and that's cool because we didn't specify the address. We are retrieving all the data from our database, but sometimes we can only want to see names of our friends. How can we achieve this? So we have to modify our query in order to retrieve the specific data that we want. Let's write select space the field that we want to select from our database table, which is name in our case, because we just want to see Jonathan, Mark, and Maria. Select name from the table which is contacts, semicolon, and let's go. You see what we have now? The name, which is the header, and the names. We can come again and just get what? The phone. We have, do you see, we are modifying the way that we query our data. We simply want these fields so we don't have to get everything from our DB. Here we have the addresses are here. So it's cool to learn SQL, it's cool to know these commands because they are going to be used when you create a database, and you've already used it now. Memorize this, revise in order to give value to what you have learned right now. SQLite in real world doesn't have data types for the fields that you store data. When you write a data type, is to let you simply know your intention, that you want to store that specific data type in that field. But why we write the data type as we've written here, text, integer, and text? We do this just because SQLite is a tool that implements the standard SQL in its root. That's why it still uses the standardized pattern that SQL has for creating tables, where columns have to have the data type specified when you are creating a new field in the table. So I hope you've enjoyed the lesson and you learned something new. We're back. Introduction to SQLite Part 2. Today the first thing that we're going to do is to insert a string type in an integer specified column. Remember what I told you in the last lecture. SQLite doesn't have types for the fields of data. When you write a database, it's simply to let you know your intention to store that specific data. We're going to insert a specific data different from the specified in the field, and we're going to talk about that. Next, we're going to see how to update data and delete data in our database. Finally, we're going to see some useful commands of SQLite 3. Without further ado, I want you to be ready and let's go. Open your command line or your terminal, in my case is CMD. I'm going to put it in the middle and increase its height. Our database name is friends.db. So what we have to do to open that database is write SQLite3 space friends.db. Hit enter, and here we have. Let's retrieve all the data so that we can see if our data is still inside of our database. We know how to retrieve data. Select all the records from the table contacts that's inside of our database. Contacts, semicolon, hit enter. We still have our data. That's very beautiful for us. Now, what are we going to do? We're going to insert a different data type in the column of phone, which is integer in our database. To do that, we need to simply use the commands that we know to make the insertion. So let's write those commands. So it's insert into our table, which is contacts, and the values are Max is a simple name. The font we have specified as integer. Now we're going to insert strings. We are inserting as a string because the phone number is between quotes, comma, last the address, let's say Cape Town, close, semicolon, hit enter. Let's retrieve the data and see if the data is there. You can navigate through the previous commands that you've written in your command using the up and down arrow keys, and if it doesn't accept, you can simply write again, select all from contacts. I'm going to navigate up arrow key. This is the command that I want to write again. Hit enter. I have as the last record Max 5627 and Cape Town. Well, you see that we have inserted a string type in the integer specified column. Well, we can insert data and have problems when we retrieve that data to an integer variable. So although you can do that, it's not preferable to do. So the best thing is to insert the right data type that you have specified as your insertion to be stored in the column that you want to store the data. Now that we've seen this part, and now it's time to talk about the update and the delete statements. Update is necessary in any application in our daily basic life because we need to change the data that is stored. For example, when you make a post on Twitter, you may want to edit that post. It's a tweet, better saying. You may want to edit that tweet and you have the possibility to do so. You may have done a mistake, you may have made a mistake when you were making the tweet and you need to update that information. Tweet allows us to do that, and we may want to delete a record in our tweet. So when we use the commands in our mobile phone or our smartphone or our computer, we are directly contacting our database to perform the update and the deletion operations for us in our database of Twitter. Well, how do we update the data? Before we update, I'm going to tell you how to make the backup of the current database in your SQLite 3. We use the SQLite 3 command dot backup space the database name that's going to contain the backup of this database, which is friends. I'm going to say friends data backup v1. Hit enter. I have the backup. Well, to update we use SQL commands. Update space the table, which is contacts, space set space. What we want to update? We want to update Mark's name to become Jeff. So let's change where the column is name to be equal to Jeff and semicolon. What is happening here? We want to update the table contacts and set the column name to become Jeff. Our intention is only to update Mark's name to be Jeff. Okay, how we want to update? Now we simply have to click what? Click enter. I'm going to ask you, do you think that update has already occurred? My answer is that update has occurred, but not the one that we desire. The update command updated all the names to Jeff, and that can be a mistake in a real-world production database. So be careful when you use the update command. Update command is so powerful because it allows you to update a huge amount of data in a single statement, and can be dangerous at the same time because the wrong usage can lead to mistakes. For example, now imagine if we had thousands of records, we would have updated everyone's names to Jeff, and not everyone is Jeff. Let's go and see what's inside of our database. Do you see everyone now has the name of Jeff? That's wrong. So now you have in mind also something, the importance of making backup of your database before you make a change. Let's go to our SQLite command and restore our database. How do? We write dot restore space the database name that we have used it to store the backup of our current database, which is friends data backup v1. Hit enter. Now let's retrieve all the data and see if we have the data. Here we have cool Jonathan, Mark, Maria, and Max. We want to update only Mark's address right now. Only Mark's address, not only Mark's name to become Jeff. What we have to do? Well, we have to write update space contacts, which is the table, space. We want to set the name to become Jeff, and here we use the where clause. Where what? Do you see that Mark's address is California? So we can use the field address equals to California. So this command is going to look for the address California in our table contacts and change the column of name to become Jeff. Let's hit enter. Now let's retrieve all the data from our database and see if we have Jeff where was Mark. Here we have Jonathan and Jeff. It's important to know how to use the update command. Be careful when you use it. Now that we have updated, we may also want to delete some record here. How do? To delete a record, we use SQL statement. How we use the command or statement to do this operation is delete space from space the table name, which is contacts. Be careful. If I run this command, how it's now, I'm going to delete all the records. So we have to use the where clause. Where, let's choose to delete what? The max record. So we can say where name is equal to max, only max, and semicolon, finally enter. Let's retrieve all the data from our database, and now we see that we don't have max record. Well, where clause is not only used to operate with updates and deletions. We can also use the where clause to query data. Until now, we've been querying all the data from our database. Imagine that we want to check the address for Jonathan. How can we do this operation? Instead of retrieving all the database, what we want is just to retrieve the data from Jonathan. So we can combine the select statement with the where clause. So let's write here, select what? Select all the columns from the table contexts where what? Where the name, which is the column, is equal to Jonathan. Semicolon, hit enter. Do you see what we have? We have only the Jonathan's records. I forgot to use the headers simply to show you what column is the first, the second, or the third. It's just to give you a label for the columns. You may not know what Jonathan means, 54837 means, and London means. We just simply have to turn on our headers as we did on the previous lecture. Headers on, and now we can query again. You're going to see name, phone, address. It's simply to give us these labels right here. Well, now it's time to talk about the commonly used commands in SQLite3. I'm going to talk about the schema, dump, and tables. Tables is simply to retrieve you the tables that you have in your SQL database. We just simply have to write that table, and here we only have the contacts tables. Now we are going to make a conversion of the entire structure of our database into text. We have a command to do that. The command is dump. Do you see? All the insertions that we have made are here, and our table is also there. If we want to create this table somewhere, we can simply copy these commands and paste it where we want. Finally, I'm going to talk about the schema. The schema is simply going to give us the structure of our database. That schema. Do you see? Our database table is a name, which type is text, phone, integer, and address is a text. So these are the basic commands that you should know if you are working in SQLite. You should know how to insert, retrieve, update, and delete data. What you already know until now. You know that you can insert different data type, but it's not a good practice to do so. Now I want you to revise this content, do it again, change the data that you have in your database, and you can move to the next lesson. This is the end of our class. You are ready to do the operations that we've seen so far. We're back to the SQL database with Java course. Data query in SQLite database with SQL. Before we move on, please make sure that you are following the tech skills on these two social medias and give the feedback right there. Be ready and let's go. Well, I'm going to first open my terminal, and here I have. We will query more data in SQLite. In our previous database, we had stored a small amount of records, and it was so easy for us to query that data since we could simply retrieve all the data and scan through each line and just retrieve the necessary information for our need. For this lecture, I've prepared the database with a bunch of songs, albums, and artists so that we can have more data to play with and learn. I have here this database. But before we start talking about this database, I want you to also know that during this course we will use the SQL join clause to link the tables, and by linking tables that may result in complex queries. Then we will see the views where we're going to store our queries and use the queries whenever we feel the need. Now it's time to download the file which is in the resource of this lecture. Save that file in a good place for you, preferably where you can have access. If you store where you don't have user permission, or you may not be able to open the file. I have downloaded that file, extracted, only retrieved what really matters, this database file sound. And I've saved it on the path where my terminal is currently in. C folder users Dalton Kifala. Save where you want, but you have to change the directory of your terminal to also be there. For example, if you save on a desktop, you have to navigate through your terminal and change it to desktop. For example, I can say cd desktop because desktop is a child from Delton Givala's folder. Hit enter and I'm here. I can say dir to list all. I have that file sound.db. I don't want to use this file on my desktop just for organization purposes. I'm going to cd backpack cls. cd may not work on your operating system, so you have to navigate on the internet how to change the directory of your terminal in your specific operating system. Save where you use it to save other database or where your terminal is currently showing you. That's the easiest way because you have access to that path. Well, I'm going to open the database SQLite3 as usual, sound.db. Hit enter. Cool. I want you to retrieve me the structure of this database. That schema is the command with S. And here we have the structure of our database. 3 tables. Albums have how many columns? 3 columns. The ID, integer, primary key. Don't worry if you don't understand what primary key means. Name, text not null. Don't worry if you don't know what null means. I'm going to be explaining this in this lecture. That's why you are here to learn. Create table, song, ID, primary key, track, integer, text not null, album, integer, create table, artists, and ID, primary key, name, text not null. Okay, these are the tables that we have. The first thing that I'm going to ask you to do is simply to retrieve me all the artists that are stored in the table. Artists. Select all from artists. We have 40 artists and they are here. You can see that each artist has a unique number here, 1 2 3 4 5 6 7, and each number is associated with a specific artist. For example, 13 is Rihanna, 15 is George Michael, 23 is Maroon 5, 25 is Taylor Swift, 26 Ariana Grande, and so on. 40 is Usher. This is the ID and this is the name for each artist. ID is simply a unique number that a table contains to identify a unique record and guarantee its existence only once. For example, Eminem will exist only once and we have associated it with an ID which is 20, and the name that we have used in our case is _ID. Some classes in Java, the programming language that we're going to be using later, require that the ID column to be named _ID. If you write _ID is bad, but if you don't, okay, it's not bad. But you have to know that some classes require that. Next, I want you to retrieve me all the albums that are stored inside of our table. So you just have to query. I'm using the down arrow key, up arrow key to retrieve the previous commands that I have written. If it doesn't work on your machine, simply write, hit enter. Okay, I've written scheme. Okay, let me go and write select all from albums. We have all the albums here, 72. Looking for myself, the Christmas, twice as tall. I'm going to explain what each record here means. For example, I have here 57x34. 57 is the ID of each album. Albums are stored individually. Each album is unique. The name of the album is X, and 34 means, according to our schema, ID of the artist if this album belongs. We have 34 here. Album X belongs to the artist whose ID is 34. We just need to come here and see who is 34. It's Chris Brown. This album belongs to Chris Brown, the album X. Retrieve all the songs. All you have to do is write songs right here. Do you see we have 957 songs? I'm going to explain what each record means. For example, 931. The first Column here means the unique identification or the identification of the song. In this case, we have 931. This song is unique. 11 means the track's number inside of the album. For example, Rivals is associated here with the album 70. 70 is the ID of the album. So the Rival song is the track, has its track number 11 inside of this album 70. Now I want you to tell me who is the author of this song Rivals. Well, let's combine some queries. We know that from this song we don't have enough information to get directly the artist who sings, but we know that we can see in which album this song is present. Then if we know in which album the song is present, we can query who sings the songs on that album, or in other words, to whom this album belongs. What we're going to do now is to get only the album's name where Rival song is. So we're going to select the name from albums where underscore ID is equal to 70 and hit enter. Hard to Love is the name of the album. I'm going to turn headers so that you can see headers on. You can see what it means, and here we have the name is Hard to Love. Let's query all. Let's query all. We have the ID is 70, the name is Hard to Love of the album, and the artist is 40. Okay, now we can see who sings this song, because that song is inside of the album Hard to Love, and we know that album is associated with the artist number 40. Let's come here, select all from the artists where underscore ID is 40. Cool. Asher is the singer of this album and the song that we were looking for. Right now, we're going to find this information by ourselves for somebody, randomly confirm with our own eyes. Let's retrieve all the artists, select all from artists. We have here, for example, Ariana Grande is 26. Cool. Then I'm going to select all from albums. Okay, I have here Ariana Grande's album, which is Thank You Next. You want to confirm that this association 26 is correct. All you have to do is come here and see 26 is Ariana Grande's album. Is that true? Let's go back, and here we have 26 Ariana Grande. If you want to go to the internet, you can see Thank You Next is Ariana Grande's album. Let's back up our database. To do so, we have to write backup. I'm going to say sound backup v1, and I have done. Let me retrieve the schema right here. I want to talk about some technical concepts with you. In SQL database, the rows don't have a defined order. You can see here they are in a defined order. A key is an index used to speed up the query. When we define the keys, we are saying that the data in should be ordered in that column or group of columns. As a result of doing that, the search of our queries work faster. You can have many keys but only one primary key. For example, here we have the primary keys and they are unique. You can come here and try to simply store a new record or a new artist. I'm going to be specific with the ID 40 or an ID that has already been used, because ID is used to identify a unique record. You can have keys that are not unique, but the primary key needs to be unique, and we have defined ID as the primary key. For example, A name can be a key, but not primary key, since more than one people can have the same name. I can have two artists with the name Justin Timberlake, but in our database we have to store them as different records. Let's see if that's true. I'm going to try to store someone with ID 37 Bruno Mars in our table artists. Insert into artists the values 37 Bruno Mars, and I'm going to say now I want to insert Jackson. It won't work. Unique constraint failed. Artist dot underscore ID. What happened? It found another record with the same ID right here, and you can't do that. I'm going to simply delete this and write Jackson. Okay, and insert into artists the column name. Hit enter. What happened right here? What happened? Insert into artists. Okay. I'm going to open my database again. SQLite3. That happened because I have written a token right here. So let me open again. This is sound.db. That schema. I'm on the right place, and I'm going to insert into artists in the column name Jackson. Cool. Now I want to retrieve all the information. Select all from artists. I have Jackson. Did you see what happened? SQLite generated automatically the value to the primary key. If the value is not specified, it will generate automatically. But we can also specify. In our case, it was generated automatically because we didn't specify. But if we specify, that value needs to be not stored in our table as a primary key. Let's talk about not null. What not null means? Well, not null means this column is obligated to have value, and you can't add records without a value on that column. For example, we have to add an album if we have a name right here. We can't add an album without a value on the column name. It doesn't make sense to store an album without a name, to store an artist without a name. Doesn't make sense to store a song also without a name. That's why we are obligating user of this database to insert a name here. You know how to query. You've seen that these tables are associated in logical terms, and you can play with data if you want. This is the end of the class. You are on your new section of the course. This is going to be an overview of what you're going to get around this section. Without further ado, let's go. Well, our main idea for this section is to order our data with criteria, make joins of tables, make views, and more advanced queries. This is our core idea for this section. Well, what you're going to learn and what you should know at the end of this section is to use the order by clause to order your records by some criteria. We just don't want to retrieve our data without being ordered in some criteria sometimes. So you're going to learn how to do that. You're going to learn how to make SQL joins of your tables or make relations between them. Third, you're going to make complex joins. Next, you are going to learn how to create wildcards and views. You should be ready right now and excited to go. Manage the state that you're in because study is state dependent. And let's move to the next part. So this is the end of the class. Welcome to this course again. We're back to the SQL database with Java. We're in the section SQL joins, order by, queries, and views. This is the tech skills giving you this course, and today we're going to see the lecture playing more with data, complex SQL joins. So be ready and let's go. Let's open our database again here, SQLite3 sound.db. just see the schema. Okay, that's good. I'm going to give you a simple small problem just to select me the album's name, the song track, and the song title from our database and order these results first by the album's name, then by the song's track. After you make this challenge, come back here with me and see the result. Okay, I hope you have figured out how to solve. We have just to select. Now let's pass the tables that we are interested on. Albums dot the name of the album, comma, songs the track. Next we want the songs, the title, and what are the tables from songs in a join. Okay, in a join is going to select all the rows from both participating tables to appear in the result if and only if both the tables are going to meet the condition specified in the on clause. We didn't write the on clause and we're going to write it now. Okay, save this idea and you're going to need it whenever you are performing queries using joins of tables. So select albums that name, songs that track, songs that title from songs in a join. What? Albums on songs that album. Songs that album needs to be equal to album that underscore ID. Okay, I've written album. It should be album here equals to album dot underscore ID. And I told you that I want the results to be ordered, so order by what? First by the albums that name, then by the songs that track. Let's hit enter. Okay, no such column album that ID. Okay, let's come here, albums that ID. And here we have our results. As you can see, we have the album's name, the song track, and the song title from our database, and they are ordered by the album's name followed by the song's track. As you can see, we have Thank You Next, the song track here in order, and everything is working how it was expected. Now I want you to solve a simple problem that I'm going to give you. Again, the problems are simple according to your application to the task. I want you to retrieve me the artists with their albums in the alphabetical order of the artist name. I'm going to give you some 10 seconds to solve this. Pause the video at this moment, solve the problem, and then come back with me. I'm going to show you the answer for this problem. I hope that you have figured out how to solve it. Well, we have to select simply the name of the artist and the album, and we know what are the tables that are participating in these selections: the albums table and the artists table. So we have to make the join of that where we have common values, and we're going to use the IDs of the artists and the albums to make this operation. Then I want you to give me the result in order of the artist name. So without further ado, let's write here so that you can see. Select what? The artist name, albums name. We are selecting the tables that we are interested from what? From albums in a join artists on albums that artist. You know that albums that artist is holding the artist to which the album corresponds. Artist is going to be equal to artists that underscore ID. Now I want you to order these results by the artist's name. Simply artists dot name. I may be slow when I'm writing because I want to explain you and let you have time to absorb. And the next reason is I'm not used to write using the keyboards that I'm using now to produce this course. Okay, select artists that name, albums that name. From albums, in a join artists on albums that artist equal to artists that underscore id in order by artists that name. Let's hit enter, and here we have our result. Okay, take time to appreciate what you have on your screen. I didn't turn the headers. Maybe it was necessary in order to tell you what we have as result. Okay, but here we have that headers on. If you want to know, we have here, okay, everything here. We have selected only names, so we have here name, and the results are here. The first column corresponds to the artist's name, and next is album. We've simply ordered it by the artist's name. For example, we have here Ariana Grande, thank you, next, Mario, everything, Burna Boy is right here, African Giant, twice as tall, Chris Brown, X, Smiling B, Indigo, and so on. Okay, we have Drake, Scorpion, X, and so on. Now we're going to see something more advanced. Until now we've been querying and doing awesome queries, but now let's see this problem that we have. Imagine if we want to know who sings a song. We have many songs here. Until now we've just seen to which album the songs correspond, but let's suppose that we want to know who sings that song. Is the most natural question that someone makes when he listens to a song, and our database contains that data. But as we can see from our schema, our songs here are not directly linked to our artists. Our songs are linked to a certain album right here, and the album is linked to the artist. So to know who sings a song, we need to know to which album it belongs. Then we need to know to whom the album belongs. That's it. For example, we have a song A. We're going to know what is the ID of the album to which the song A belongs. Okay, we're going to see that, okay, the song belongs to the album which the ID is equal to B. Then we're going to see, okay, album B, who sings the musics here of the album B. Okay, album B is going to look for its artist column. Okay, and let me retrieve the name. Okay, the name is C, so who sings these musics is artist with the value C. A, B, C are just arbitrary letters that I've used to represent a scenario. How can we do this? Okay, first we need to join the songs to the albums and then the albums to the songs. Remember what I told you when we started. We're going to see joins inside of joins. First, what we're going to retrieve, let's combine. We're going to retrieve the artist's name, the album's name, the song track, and the song title. So let's select what? Let's select here the artists. We want the name. Now we want the album's name. We want the songs, the track. We want the songs, the title. And let's select the tables that are going to participate in this join. It may be a bit confused for you to understand how this query as a whole is being written. So I'm going to hit enter and go to the next line. SQLite is not going to execute because I'm not going to press enter with a semicolon. So here we can still write. Select artists that name, albums that name, songs that track, songs that title from songs. Now in a join what? In a join albums on songs that album in this field equal to albums that underscore, okay, underscore I mean ID. Okay, we have this first part, and now we have to simply join again artists on albums dot artist, because we have a field albums that artist that we want to match. Also albums that artist needs to be equal to artists that underscore id. Okay, as we have this result, let's order by the artist name and album name and song track. Hit enter again, order by artists that name, next the albums that name, finally songs that track. Let's read our query. Okay, select artists that name, albums name, songs track and songs title. The first tables that are going to be participating in this relation from songs in a join album. Okay, albums on songs that album equals to albums that underscore id, then in a join artist on album that artist is equal to artists that underscore id, then order by the artist's name, the album's name, and finally by the songs that track. Okay, we've read our query, and now it's time to make what? It's time to execute and see if we have the desired output from what we've written in our. But before we do so, I want to correct right here. We have artist while the table is not artist. Okay, we're going to correct it right now. Okay, let me write the order by again. I've deleted, so let me order by what? Artists that name, albums that name, and songs that track. Okay, this is going to fail because here we should write artists and I didn't write. Okay, no such table artist. I could guess that it would fail. What I'm going to do now is to write it, so I'm going to back. For here we don't have any problem. Let's come here where we have the inner join. What's going? Okay, I don't want this. Where we have the inner join. Okay, inner join albums on songs that album equals to album that underscore id. Cool. The next inner join was that one. Okay, I don't have that inner join right here, so I'm going to write again join artists with s, artists on albums dot artist is equal to artists dot underscore id. Okay, now let's order by artists that name, albums that name, and finally songs that track. Let's hit enter, and here we have our result. Okay, what was missing was the s. Here we have the result. We know that Whiskey sings sounds from the other side. Number 1 is the number of the track. Okay, sweet, come closer, now the right, the African bed, the daddy-o, and so on. We have here circles round and round, 2 days, 3 songs. This is exactly what we wanted. We know who is the author of the music, we know what is the name of the album, we know what is the track, and we know the title of the song. Okay, you can go scroll on and appreciate these results. I want to tell you that we can combine the joins to produce the outputs that we want. Now we can also specify to which albums we want to retrieve the data, for example. And here is where we're also going to combine with the where clause that we have seen in the select statement. Okay, let's take someone here whose album ID is going to be something like 38. Let's make something different now. Let's select artist name, album's name, song track, song title, okay, from songs. This is the first thing that we're going to do. If you can't use the up arrow key and down arrow key to navigate through the previous written statements, simply write and follow me. That's how you can learn. Hit enter. Look for that inner join here, the first one, songs that album's ID. Now the last inner join that should be here. Okay, we don't have that last inner join. Okay, what we can do is simply write albums that artists. Okay, inner join it should be now with another table which is artists. Okay, with these artists on albums that artist is equal to what? Is equal to artists dot underscore ID. Let me see if I've written correctly. Okay, now I've written inner join artists on albums that are okay, albums that artist right here. Okay, is equal to artists that underscore, oh no, artists. Cool. Artists is equal to artists that underscore ID. And now I want simply where the albums that underscore ID is equal to, let's say 10 for example. I had say 38, but let's just change. And order by, do I find the order by? Okay, I find. Okay, no such column, albums that artist is okay, albums that artist. You can see when you make something wrong here, you have to write again. Okay, here we have the result. End of the class. Please revise. Sorry for some mistakes. We're back to one more lecture. Be ready and go with me. I have here my computer. Let's jump to our console and list all the albums that we have inside. List all, select all from albums. Okay, and let's see. We have many albums right here in our table. I want you to imagine a scenario. We think every day we are living in a hurried life. Sometimes we don't remember very well the name of things. If I want to know what is the complete name of an album in order to query here in my database, I really need to know all the complete name of that album. Well, but what if I remember just a part of the name that composes that album? It would be very beautiful for us if we could retrieve the album's name by knowing just a certain part of its name. Fortunately, we have how to do that. And I believe that you've been doing your queries in the real world, not writing all the entire name of what you really want, but writing a certain part of what you want. Then your computer performs the execution of a smart code that a smart person has written for you in order to retrieve what you want. Okay, you can see that I have these commands right here that we've been using in our previous class. I've written them here in this text file because it's overwhelming for me to write these commands multiple times, and I believe it's also overwhelming for you. Fortunately, we're going to see something today that's going to allow us to have a table that contains some information that we want instead of just having to query every time. I have a new for you, and the new is right here. Okay, this is about wildcard. Look at these statements that I have here. select artists.name, albums.name, songs.track, songs.title from songs in a join albums on songs.album equals to albums._id. Okay, then join the artists in order to have the artist name, the album, the song, and the title. Here you may be seeing some difference. Now I have where albums.name like mbres. What I want to do when I write this, I want to retrieve data where the album's name contains mbres. I don't know what is really inside of the name. It's a partial knowledge that I have about a specific name. The percent that you can see here is the wildcard character in SQL, and we want to query something that it's like what's between these percent characters. We have more characters, you can look for them on the internet, but I'm going to tell you probably the most used one. Between percent you write what you think it's there in the album's name. Okay, let's see what we have here. We have everything, we have evermore. I know that it contains ever. I can come here and simply change for ever. When we use the search, it's not going to be case sensitive. Let's copy and put it in our console. Paste, and we are ready to go. Hit enter. Okay, do you see what we have here? Albums.name is like ever. We are sorting these results. There is name, album's name, song track, song title, where the albums is like to have ever. Then I can see the results. Oh, my everything. Okay, Ariana Grande has ever. Okay, cool. The DJ Khaled with the best song forever. It's because of this ever at the end. Taylor Swift, evermore. Okay, we have our results. This is so used in real world situations because you don't know the names of everything, but you know some hints of the name. Let's make the same but for the song title. I'm not going to be writing here everything because it takes so long. Paste. Okay, instead of something here, I want to change. Okay, something, maybe I want to find a song in which the title has something. Let's query. Okay, we have we have Drake's songs, More Life, track 13, Nothing's into Some Things. Okay, then Justin Timberlake's Man of the Woods, number 9, Say Something. Correct. It helps us in such a way that we can retrieve data from some kind of patterns that we know or hints that we know. It's overwhelming to write this kind of commands repeatedly. Some databases allow us to store queries with some parameters in some cases that are going to be changing according to our needs. Well, SQLite database doesn't allow us to do this just because of its own purposes. This is not a client-server database. It's more a database to be embedded on a specific system, and we are managing our database using the code. But in real world situations, you don't write the queries. You just use a client service. You make the operations using a graphical interface in most part of the time, and the database management system in your client side is going to communicate with your database. In other words, it's going to run these commands and retrieve for you the result. The technology that allows some databases, for example, to store with the queries with some parameters in some cases is known as procedures. We don't have in SQLite, but we have something that is going to help us, which is the views. Imagine views like a virtual database where you can add, edit, delete information, and it's like a replica that you're going to give to people. Treat a view like if you were treating a table. I'm going to come here, write down, and introduce to you this concept with code. Here we have the first view. We create view artists list as keep in mind these keywords. Create view, we'll use it, right? Create table, but now it's a view. Okay, create a view, create view only, and the name of this view is artists underscore list s. Now select these columns that I want you to insert on the view, make these joins and order by artist name, album's name, and the song's track. What is going to happen here? We're going to have a fantastic result. We're going to have a table containing all the results. It's powerful for us. Let's just copy and paste in our command. Hit enter. Cool. If we want to see if that was really created, let's just get the schema of our database, and here we have select the artist, that name, and so on. We have our view right here. We can retrieve all the data from our view. Select all from, but before I do so, let me turn the headers on. Select all the data from artists underscore list, and let's go. Do you see? I didn't write all those overwhelming and boring queries in order to get this result more than one time. Now I have that result. I've just written that view and used that view like if I was using a table. Here you have 3 songs, back home, be my guest, and the track is 1, and so on. Do you see how it's powerful to have this table? Mr. Ball, Romantic, and so on, Maroon 5, V1, Maps. You have all the data. You're not seeing more data here because, okay, the terminal also limits the amount of data that it's going to show. But here we have all the data. It was easy for us. Now, I want you to see another view right here. But before we do so, let's come here and simply do what? Simply list all the albums. I think we had listed, but let's just list again. Select all from albums. Cool. If I want to give someone the albums from my database, what really matters for the person who wants the names is the name and not the IDs or other data that we as the architects of the database are using in order to make the relations or the structure of the database. What if I create a view containing only the name of the albums and order them by name if necessary? Create just a table containing the name, only that, because the ID doesn't matter for me. If I go to a song service, let's for example assume Spotify, I write the name of the music, I click on albums, I get the albums names, I don't get the IDs of the albums. Let's just make the same for our application. Here we have the view. Let's just paste, go, and select all from albums underscore list and see what we have. You see, we just have the names. That's what really matters for us. We don't want the IDs and we don't want any other thing that you have been inserting into the structure of your table that contains the albums. This helps us a lot, and what it does at the same time, it allows us to provide data that is needed instead of data that it's not needed, adding more security to our applications. Imagine that you have a table containing sensitive information from your user, for example his password, his name, his bank account details, but somebody else just want the name of your client. You won't retrieve all the data that you have about the person, but you will just retrieve the data that matters and can be sent to the person who is asking. So with that said, we have seen queries, views, wildcards, This is the end of the class. Please revise. Don't hesitate to post your questions on the Q&A section. We are back to one more lesson of your course, the SQL database with Java. Be ready and move on with me. Before I give you the challenges, I will show you a command that is used to count the amount of data that we have in our database. For example, let's say that we want to count the amount of songs. All we have to do is to use the command select. Okay, now we have to pass a function which is count asterisk all from our table songs 957. This is the amount of songs that we have in our table songs. This command is important since you may want to know the amount of records that you have in your table. Okay, do the same right now for the albums. Up arrow key, albums, 72 albums, and for artists, okay, all we have to do is artists, and we have 41 artists. Well, the first thing that I'm going to do now is to retrieve all the albums. Select all from albums. Okay, I should just select the names, but let's select the albums right now. I want to show you something. 72, it's correct. Okay, 72. Let's choose an album right here. Let's come to this one, 24K Magic. 24K Magic is going to be the album that we're going to play with. I want you to select the titles of all the songs on the album 24K Magic. This is the first challenge. Pause the video now and come back when you have the solution. Select the titles of all the songs that are inside of the album 24K Magic. Let's do it. Okay, I hope that you figure it out. All we have to do is to select what? Songs, the title from what? Songs in a join albums on songs that album equal to albums that underscore id where clause where what? Albums that name is equal to, I say, 24K Magic. And let's see if we have, okay, Chunky Perm, Versace on the floor, straight up and down, calling all my lovelies, finance too good to say goodbye. These are the songs that are inside of the album 24K Magic. Cool. Now I want you to do the same, but show me the songs in the track order, and you have to print the song so that I can see if that's really working or not. Okay, all we have to do is to select what? Now we want the track, songs, the track, songs, the title, from what? From the songs in a join what? In albums on songs that album equals to albums that underscore id where clause what? Where the albums that name is equal to 24K Magic. Wow. Order the songs by the song track. Order by songs the track. Okay, select songs the track, songs the title from songs in the join albums on songs that album equal to albums, okay, as we have here, that underscore id where albums that name, Okay, it's missing here, equals. Okay, where is equal to 24K magic, ordered by songs that track. Let's go. Okay, we have chunky perm, that's what I like, recession on the floor, too good to say goodbye. Okay, likely is the same order, but we have made here. Display all the songs that belong to Justin Timberlake. Pause the video and do it by yourself. Okay, I hope you have figured how to do that. I just want the titles of the songs. That's only what I need. So select what? Select songs. That title, this is the final from all the joins that we're going to be doing here. Select these songs, that title from songs in a join with albums on songs that album equal to albums the underscore ID in a join artists on albums that artist equal to artists the underscore ID. Okay, where artists that name is equal to Justin Timberlake. Okay, Justin Timberlake. Let's read our query again. Select songs, the title from songs, okay, in a join albums on songs that album equal to albums that underscore ID in a join artist is albums that artist is equal to artists that underscore ID where artist is that name equals to Justin Timberlake. Okay, run. Wow, TKO. I like this song. We have Justin Timberlake's song here, all of his songs. TKO, True Blood, Drink You Away, Murder, Tunnel Vision, That Girl, Mirrors. You have completed this challenge. See some artists that we have here. Select all from artists. Okay, from. Change Jessie J to become Jackie J. Okay, it's just to update artists set name equal to, this is our name that we want, Jackie J, where artists that name is equal to what? Jessie J. Oh, what happened? Update artists set name equal to Jackie J, where artists that name is equal to Jessie J. Okay, let's check if it's working. Select all from artists. Okay, I have to find out what's going on. Let me just make a Ctrl+C, error near J. Okay, what just happened right there? Something happened here. It's missing the code. Oh my god, let me open our database again. It was sound.db. Continue. Now let's run that command again and change it here. Let's query all and see. Ta-da! Now you are Jackie J. Now I want you to retrieve just the titles of all the songs of Rihanna in the alphabetical order. Just select what? We just want the title from. Remember that we have artists underscore list in our database, so let's use that view artists underscore list. We're going to do where the name is equal to Rihanna. I've written correctly, no, Rihanna, and just order by the title. Okay, close to you, consideration, desperado, high, better, and so on. Yes, it's in the alphabetical order. But for now, all I want you to do is just retrieve for me the amount of songs that I have here for Rihanna. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. All you have to do is come up here. You should complete this before looking to the solution. But let's use the function count. Okay, title. 13 songs for Rihanna. Beautiful. Okay, now retrieve me the distinct songs for Rihanna. All you have to do is to come up here, count. Okay, it's correct. But if I don't want duplication, what I have to do? I have to distinct, write distinct. Okay, 13. That's obvious because she doesn't have duplicate songs. Okay, and now let's just count the songs without duplicates. And for now, we won't have to do pretty much something different from what we've done before, because we will still select count distinct what title from, let's use our view artists underscore list where the name is equal to Rihanna 13. Cool. Now I want you to count just the number of artists, and you know what the answer should be. Okay, it should be 1. And all you have to do here is, instead of counting the title, count the name 1. Well, we have played with SQLite database tables. It's time to take this to another level, incorporate with Java. The next parts of our course are going to be more exciting. You're going to like. This is the end of the class. Don't forget to revise and follow us right here on our Twitter and Instagram. Let's move to the next part of this course. We are back to the SQL Database with Java course by the Tech Skills. We are in the section of database creation, JDBC in Java and SQLite. This lecture is about an overview of the section, what you should know at the end. So be ready and let's go. In this section, basically we're going to start integrating the SQL that we learned using the command prompt with Java. So we're going to be creating Java applications that have support to SQLite databases. What you should know at the end, first is to set up development environment. I'm talking about Java to your machine, the integrated development environment, which is the place where you're going to be writing your code, and DB browser for SQLite, where you're going to have a graphical interface to interact with your database. Next, you should know how to set up and manipulate a SQLite database using JDBC in Java. This is one of the main goals of this section, and I personally consider as the main goal of this section. Third, create database using JDBC in Java. So you're going to be creating your SQLite database using Java code in your Java applications. Fourth, make CRUD application using JDBC in Java. Everyone who is a developer and works with databases needs to know how to make at least an application that makes a creation of data to a database, reads data from a database, updates data from the database, and delete data from the database. Remove hard-coded SQL statements and reduce repetitive code with methods. This is the part where we start making our code look cleaner and beautiful. So this is what you should know, and this is the end of the class. Revise in case of need, and let's move to the next lesson. This is the section of database creation, JDBC in Java, and SQLite. Specifically, this lecture is about the JDBC and SQLite graphical user interface browser tools. Well, until now we've been working on a SQLite database using the command line. We've been writing our queries, views, tables using the command line. It's time to advance. Now we'll learn how to use database from a Java application. I think this is one of the most important parts, if not the most important one of this course for you, is where you're going to use the database from a Java application instead of only writing the database and using it with command lines. We use JDBC API to work with databases in a Java application. JDBC simply stands for Java Database Connectivity, simply as that. JDBC not only allows us to work with databases, but also spreadsheets and flat files. Is going to be to work with databases, but JDBC not only allows us to do that. Our data source is going to be a database. JDBC just acts like an intermediary between a Java application and a data source. I think now you have the idea of what JDBC is. To use a particular data source from a Java application, we just need the JDBC driver for the data source. For example, to access a SQLite database from an application, we need a SQLite JDBC driver. The driver is just a library that contains all classes that implement the JDBC API. As all JDBC drivers have to implement the same interface, it's not hard to change the data source from an application to another one, but it's not simple as it seems to be. You need to make some changes, but it's not hard if you think previously that you may be subjected to make those changes into your program. Imagine if your application uses a SQLite database and you want to migrate just to a MySQL database. To migrate, you'll have to use the MySQL JDBC driver instead of the SQLite JDBC driver and transfer the SQLite database data into a MySQL database. That's obvious, because if you want to change the database, you need to know that the newer database needs to contain the data which was stored in the previous database. In addition, you need to change the JDBC driver. Imagine that we want to work with a spreadsheet or a flat file. To do so, we'll need to have a JDBC driver that works with spreadsheet or flat file format. In addition, we can also write the JDBC driver ourselves, but just if it's necessary for the development. There are many popular databases in the world, and popular databases provide JDBC drivers because, yes, Java is a widely used programming language. Java is pretty much everywhere. Probably if you're going to create a new database, you're going to have to allow your database to be interfaced with a Java application. MySQL offers, SQLite offers, pretty much every popular database offers JDBC drivers. The JD key, which is the Java development key, ships with a database called Derby, which can be used for desktop applications or prototyping purposes. The Derby is also included in the JD key, so if you have JD key, you have that. It's a package. JDBC consists of two packages: the java.sql, which is the core JDBC, and you have the JavaFx.sql, which is optional. APIs in JavaFx.sql package are required when working with database servers. We'll start using a SQLite database. Being so, we'll need a SQLite JDBC driver. And we'll use the driver which comes embedded with SQLite, so we don't have to install the database separately. Now it's time to make the download of the SQLite JDBC, which is a jar file, and let's move on. I have here the browser opened. The link where we're going to make the download of our SQLite JDBC is this one: github.com/serial/SQLite-JDBC/releases. You have to download this file here. The version that we are using is this one, 3.36.0.1. Please download the jar file into your computer. Download it. It doesn't matter what operating system you are using. I'm using this simply because it contains a SQLite database and we won't need to make any configurations, so please download this version. Okay, because we will add SQLite to Java projects, we are not going to have SQLite conflicts in the command line of our application, and we will use the version inside of this jar file simply. Instead of we be using SQLite command line to make operations in our database, we're going to use a software which is DB Browser to interface our database with us in a graphical user interface, and that's going to be pretty easy for us. In real world scenarios, you don't write commands into your database when you want to get data from it. What you do is to use a database management system or an interface between your application and your database, just to run those commands for you in such a way that you can see the commands being written or executed. We just have the result. Okay, what program we're going to be using? Let me open a new tab. The link is SQLitebrowser.org. Let's open, and here we have, you can see what it is: a high quality visual open source tool to create, design and edit database files compatible with SQLite. You can see here more info about it. Controls and wizards are available for users. Create and compact database files, create, define, modify and delete tables, and more on what is not here. This program is not a visual shell for the SQLite command line tool and doesn't require familiarity with SQL commands. All you have to do is to click on the download part. In this case, I'm on a Windows, so I'm going to download this program for Windows. I'm going to provide you resources that you can go and check if you are using another operating system. But this program is not difficult to be installed. If you are using Linux, you can come here and see what you have to do. If you want to run it on Linux, you can look for a video on YouTube. I highly recommend you doing that if you don't know, and check for it if you are using Linux or a Mac OS. I'm not going to be teaching you using these two operating systems because I don't have. You have to download the version which corresponds to your machine architecture. In my case, I'm using a 64 bits. How do I know? Okay, I'm going to come here to my desktop, go to your computer, or just click the combination Windows E. Okay, right click over this PC, properties, and read. Here you have 64 bit. If your computer says 32 bits, download the 32 bits version. Being so, I'm going to click right here. Once it has been downloaded to your computer, all you have to do is to click over it and run. Okay, it's preparing to install. Here we have this setup wizard for us. Click next. or next. I'm going to install right now. Okay, it's installing, copying new files. This setup doesn't take so long. Okay, finishing. I do have right now. Let me go to my desktop and I have. Let's open. Okay, ignore, and here we have our DB browser for SQLite. This is all for this lecture, and let's move to the next lesson. End of the class. Today we're going to be installing JDK and IntelliJ. JDK stands for Java Development Kit, and it's a bunch of tools and packages that allow us to develop Java applications. If we want to develop a Java application, we need to have those tools. And if we install JDK, we're going to have all these tools. In other words, we're going to have our computer ready to develop Java applications. Without further ado, let's open our browser and look for it on the internet. I have here a tab opened. It doesn't matter what browser you are using. All we want to do is to download the software. Let's open here JDK and click on the first link, Java SE. SE means Standard Edition. Here we have the latest version. At this time that I'm recording this video is 16. So download the latest version that is available at the time that you are watching this lecture. Just click here on JDK, download. It's simple to download this file. And here you can choose the options. Okay, my computer is a Windows machine. If you are using another machine, you have to download the version according to your machine. Linux versions, please find which one best matches your Linux right here. macOS users, please just download right here, any of them, or is the installer or is the compressed archive. In my case is Windows 64-bit architecture, and I'm going to download an installer. Click here on JDK 16, check this box and download. The site may not be presented like this at the time that you watch this video. Okay, it's downloading and I'm going to just cancel because I already have this software downloaded. Let me open where it is and start with the installation. I already have it here, JDK 16 Windows x64 _ bind. Click on it and wait. I'm not using a powerful computer. It's simply I'm going to share with you the specs of my computer along this course, and that's why some tasks may take so long in order to be performed in its totality. Okay, the software has already been installed on your computer. Would you like to reinstall it? I'm going to say yes, but in your case all you have to do is next. That's why you don't have to worry if you already have or not, because the setup of this software is simply next, 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 and so on, as many other softwares that exist in the market. I'm going to say yes. Windows installer is preparing, gathering required information. 64 bits. Let's wait. I'm going to pause the video and come back when it's ready. But okay, it's a bit fast. Let me come out here and see. Okay, if you are installing this software for the first time, the setup wizard that you are going to have is like this one. So just click on next, and if you want to change the path where this program is going to be installed on your computer, you can change using this button right here, but I'm comfortable with the path that it's set here to me by default, so I'm going to click next and wait for the installation. Okay, it's copying new files. Let's wait. It's registering the product right now, extracting the installer. Let's wait. And it's just next, as I told you. the status, it's completing all the bar right here, and I have it already installed. Okay, if you want to access to tutorials, API documentation, developer guides, release notes, and more to help you get started with the JDK, you can just click on the next steps. But I'm not going to click on the next steps button. I'm just going to close. Beautiful. With that done, we already have the JDK installed in our machine. So this is the end of the class. Revise if you need, and let's move to the next lesson, where we're going to be talking about the integrated development environment, and we're going to be installing IntelliJ. This is the part 2 of installing JDK in IntelliJ. We're going to be installing IntelliJ for this video. Okay, IntelliJ is simply an integrated development environment. The abbreviation is IDE, which is just a code editor or a place where we can write source code for the new projects that we want to create. We can also debug the code right there. There are many alternatives when it comes to IDEs in the market. We have IntelliJ, my best choice. I think you should also opt for IntelliJ, but you can opt to any other environment for this course or for development purpose in Java. But pick one, use that one, and code. If we write a code using IntelliJ and paste it on another IDE, the output is going to be the same because the language is the same. What really matters here is to know how to write code that is following the syntax of Java. Without further ado, let's get this started. I have here the Windows browser open, so I'm going to write IntelliJ. Click on the first link here and download it. Okay, here you have more about IntelliJ. Okay, you can see even companies worldwide that trust IntelliJ idea: Expedia, Netflix, Pivotal, Twitter, Volkswagen, Samsung. New features are here. Okay, and you can see more options. IntelliJ is also used to develop Java applications, Android applications, support the language Kotlin, Groovy, Scala, and more. Our idea here is to use it in order to develop our applications in Java and work with SQLite, a SQL database. Download here and select your operating system first. For example, if you're using a macOS, come here to macOS, and we're going to be focusing on the community version for Java Virtual Machine and Android development. Select the architecture of your computer. If you are using an Apple Silicon architecture, click here. If you are using Intel architecture, click here. If you are using a Linux, click here and download it for your machine. I'm using a Windows machine, so I'm going to click on Windows and select the extension that I want to download. I'm going to download an executable file. Just click on executable file or download here and wait for it to respond to your request. It's still processing in my case. Okay, let's wait. It shouldn't take so long, and I have a reliable internet connection and it's stable at the same time. So let's wait. But after it processes right here, it's going to start with a download. Okay, as you can see, thank you for downloading the IntelliJ idea. Okay, I'm not going to download it since I already have it downloaded to my computer. So I'm going to cancel and I'm going to show you where it is, and we can start with the installation. I already have it installed on my computer, but I'm going to show you the steps on how to install it. So let's open it and wait. Okay, we have this mini window here. Let's wait and see what comes next. Current version of IntelliJ IDEA Community Edition is already installed. You wish to continue? I'm going to say yes because I want to teach you how to install. So I'm going to reinstall. You may not have this window if you don't have it already installed on your computer. So let's click next, and this is probably the first window that you have after that mini window. Click on next. Okay, uninstall old versions may not have this window also, but I'm going to select the best options here so that I can show you the window that you have on your computer. Okay, choose installation location. Well, I'm going to browse if I need to change the default location, but if I don't need to change, that means I'm comfortable with the destination folder. I'm just going to click on next. That's my case, I'm comfortable, so I'm going to click next. Go back right here, create this desktop shortcut and association with Java extension files. Next and install. Let's wait. I'm going to pause this video now and resume when it is complete. The installation is complete. So if you want to run it, you can run, but I'm not going to run. I'm going to click on finish and we're going to start running it on the next lectures. Here we have on our computer. Cool, I'm going to pin it to start. Just pin it to start. And I can remove it from here because I don't like to have many icons on my desktop. End of the class, revise if you need, and let's move to the next lesson. Let's open IntelliJ and have our first impressions. Okay, here we have the first impressions that I'm going to have are not going to be the same to you because I have already installed it and used it during my life. Okay, you have here this open tab, the first tab, welcome tab for you. On the right side, you may not have these projects because you are new to IntelliJ, so you may have the options like create new project, add new project, import it, change settings, and so on. Here you have a small menu, customize plugins, learn IntelliJ idea, and so on. Let's go to projects where we want to create new projects. If you want to open a project, you come here, get from VCS, you come here, or create a new project, which is our purpose. So we click on create new project, and Java project SDK is 16 because it's the latest one that we have installed. If you didn't install, please just download here, click on this download. If your IntelliJ didn't recognize this version 16, click on add and just follow the path where you have installed the JDK. Let's come here on program files where it is Java and select the right JDK here, 16. Click OK. But how my software has recognized it, I'm just going to leave it on 16 and next. Let's create a folder here and say first program. Okay, click on OK. The project name is going to be Hello World, and let's click on finish. Let's wait. Here we have our IntelliJ open. Here is where we are going to develop our applications. On this left side we have the window of project. Here is where we can see our project structure. We have the first program here. We have inside of it the idea folder, which was created by IntelliJ by default. We have the source folder, which contains the source of our project. We have here this package, .example.my package, and we have here a class main, which is our Java main class where we're going to be writing our code. We have here the class main, the PSV or public static void main code block, where we're going to write our code. This is going to be the thread to be executed when we start running our project. Here is where we're going to write our code logic. Before we start writing our code logic, Maybe your program didn't set up this class exactly the same way that I have here. Maybe you don't have this play button here. Maybe your class is not compiled successfully. That may be potentially because of JDK. So come here on main if that's your case, edit configurations, and please select SDK 16. Make sure that you have it selected here and click on OK. Else you can come here to project structure and select from this part. Let's go back and write our first line of code. Well, as usual, the first line of code that a developer writes in his life is to print a message, and the message is hello world. So we won't skip this tradition. Let's follow. Okay, tab, and here we can write our code. Delete that. What is the statement to print out a message in Java? We know system.out.println. Open parentheses, and between quotes we are going to write hello world. Then end the statement. Here we have. Let's just run it. To run, we just have to click here, or the combination Shift F10. Let's click and wait to see the output on our console. It's building, as we can see here from this bar. Okay, scanning files to index, and here we have hello world. So we have passed from that tradition. Hello world, you have printed hello world. We can see that our Java IDE is working fine. Our programs compile and execute. So if that is working, that's enough so that we can start working with our programs in Java and integrate SQL right here. Let's move to the next lesson where we're going to make that become a reality. We are back to the SQL Database with Java course. We're on the section of database creation, JDBC in Java, and SQLite. Database creation using JDBC in Java is what we're going to see today. So without further ado, let's get this started. Open your DB browser application and take a look. Here is where you're going to create new databases using this beautiful graphical user interface. Open your database and basically manage your database. But before we start talking about how to use DB browser, let's go to how to create these databases in Java. Come here to IntelliJ, create a new project. I've showed you how do you create a new project, in your IntelliJ. And now it's time to use IntelliJ to develop our Java applications. Here I have the main class created by default for me using the IntelliJ. IntelliJ created this by default. If you don't have this main class or this package, you can simply come here in your source folder with right click, new package. Inside of this package, right click, new class, and write the name of the class, main with uppercase M, and come here, just write psvm shortcut, hit enter, or just write public static void main. This is the default code that everyone needs when building a Java application. Well, before we start writing a code to make that happen, we need to add that JDBC driver that we have downloaded. Come here to File, Project Structure, Libraries, New Java, and I'm going to navigate to my downloads because it's right there where I've saved that file. So I'm going to copy this path, paste here, is inside of programs, SQLite, that .jar file. So let's click on OK, OK, apply, OK. Let's see if we have here we have as an external library SQL infant JDBC infant, and this is the version. We can close that. When we talk about databases, creation or connection of databases in real-world applications, usually the database is not stored in the machine where our application is requiring a connection to our database. Usually the database is stored on a server and we simply make a connection using the web. But in our case, how we're using SQLite, we know that SQLite is an embedded database. So that database is going to be inside of the machine where we are running SQLite. To make a JDBC create a connection for us in our database, we need to have a connection string, simply a string that is going to contain information about the database where we want to connect to, information like the URL, the username, the password. Without further ado, let's get this started. First, we're going to create a try and catch block. Catch because we can have exceptions during this connection. So let's catch. The object type of this exception is SQLite and just write something here saying oops, something went wrong. This is going to be the text being displayed if something that we're going to try to make right here inside of this block generates a SQL exception type. What we need to have first, we need to have the connection object. That connection object is going to represent our connection to a database. So we simply write here connection. You can see that IntelliJ is helping us bring the classes. So connection, here we write the name of the connection that we want. So we're going to say connection is equal to drive manager dot get connection, the prefix JDBC SQLite, and here we pass the path where we want to create our database. I'm going to create the database in the same path where this program is currently in. Okay, I come here, my first DB, I'm just going to copy the path and paste. You can see that I have 2 times backslash. These backslashes are repeated because one is to escape the real backslash of the path. So if you are using a different machine, you have to specify the path according to what your machine wants. For Mac users, you won't write backslash, but instead of that you're going to write just a / and 1 time. Okay, I'm going to put how it was because this is how I'm going to create it right here. Now we are ready to test if we are going to create a database with this code or no. How we make this? Right click and just run main. Let's see if we have a database right here on this section. Let's wait, it's still building. I hope to have a database right here. Let's wait and see if we have. Okay, oops, something went wrong. Let's come and see if we have written everything properly. Let's simply come here and say +e dot get message in order to see what happened. The file is really a directory. Okay, unable to open database file. That's beautiful. Why that happened? Simply because the path that we have specified is simply a directory. We have to specify the name of the database that we want to create. So get used to have errors in your program. / and write the name of the database that you want. We're going to say my first DB in Java.db. Let's run it again and see if we have this error. No, we don't have, and our database has been created here successfully. As a developer, you need to be aware of every situation and know that errors are just a normal process of development. Here we have our database. It has been created successfully. To create database, we use the driver manager. Some people use the data source object, which is more preferred, but we won't use a data source object just because we're not dealing with large scale program. Data source object offers you the abilities to work with distributed transactions, connection pooling, but we don't need that in SQLite. Okay, now that we have created our database, it's time to execute what? SQL statements, of course. How we make that operation? To make that operation, we need to create statement objects. Let's create the statement object here and write the name statement. This is going to be equal to connection.createStatement. So our statement is connected with our connection object, which is connected with our database. So there's an association between our statement object and our connection object. So what we make with the statement object is going to be reflected right here on our connection, and our connection has the path to our database. Let's right now execute the SQL statements. How we make that? We just write our statement object.execute, and here we write the statements that we want to execute, SQL statements. Let's create a table that's going to contain contacts. You can see here inside J giving you some hint here. The parameter is SQL. Let's just create table, write the SQL statements as usual. Contacts. We're going to have a name, its type is going to be text, a phone, which is going to be an integer, an email, which is going to be of type text, and a semicolon right here. Well, I don't need to put a semicolon inside of this SQL statement because the execute method understands that the SQL statement is complete and it executes. Once we finish using our database, we need to close the connection to our database and we need to close all the statements. The first thing that we do is to close the statement, finally the connection. So statement.close and connection.close to release the resource. Let's run this and see what we have. I hope to don't have an error. Success. How we're going to make sure that our databases have been created? Our database, because it's one and we have this table. Let's use the DB browser to help us in this process. Come here and open a database. Where we're going to find our database, we're going to find right here on the same path where our program is. So let me copy this path, come here, paste, and click on my first DB in Java, open. You can see that you have the table, which is only one, in this contact, and here you have the fields, the types, and the schema. So we've created that database. Beautiful. How we are using this software, DB browser, to access our database. This software holds a lock for that database. What that means, you can't have any other program trying to use that database right now because it's locked by this program. So you have to close the database if you want to use somewhere. Let's come out here to our project, and I want to show you something more interesting also. Sometimes you may not want to write this codes to close your connections or your resources. To free up these resources after we use them, we have to use a recent feature of Java, which is try with resources. Try with resources simply is going to close to you the resources automatically after you execute the try block. How we make that? We open and close parentheses, then we paste right here inside of the parentheses the resource that we want to close. Once we execute them, these two, so come out here, paste them, and what we have to do right here is just comment or ignore them. And here we have statement that execute stays here, and we are ready to go. Let's run it again and see if we have an error. The unique error that we can have here is just missing database. Table context already exists. That's fine because we know that table context exists, but it's running properly. If you want to create a new table, you can just write something random here in order to see if you're going to have everything working fine or not. Okay, everything is working fine. I'm going to use the software to delete the last table, so I'm going to delete. Cool. Close the database, save. So this is what I had to show you today. This is redundant, so you can eliminate. This is also redundant. Why? Because this is being closed here by the try with resources, so we can simply remove. Let's remove, and here we can run it again. We're going to have everything working fine because we have deleted this word table that we don't want, but I'm just leaving here in order to get something being executed without errors. Okay, we have, but let's just remove that. I open this program and remove the table that we had created. Okay, open DB. Where is our program? It's right here, so let's copy the path, paste here where our DB is, open it and remove this last table. So let's delete, yes, close database, save. Okay, minimize. This is what I had to show you for today. This is the end of the class. Please revise in case of need. We are back to the SQL database with Java course. We're going to see common database operation using JDBC, insert, update, and delete. So without further ado, let's open our coding environment. On the last lecture, we have developed our program until this stage. Let's run again and see if we have any error. It's parsing, finished, and we have something went wrong. SQLite error. Well, table context already exists. Don't worry. Let's come here and remove that code inside of parentheses. We don't want to use try with resource. Now we're going to close the resource by ourselves. Why we're going to close? Just because we need to get used to know how to close the resources and close the resource. So let's just write statement that close, and lastly close the connection. Run again. We should have the same error because we didn't write code to handle this. Okay, we have. Cool. Well, what's happening is that every time we run this program, we create a connection to our database here located at this path. We will create a statement object from our connection object, and we execute this SQL statement, create table contexts. Notice that every time you're executing the same command to create the same table, and you can create more than one table with the same name in SQLite. They should be different entities. That's why we're having this exception here being thrown. How we can handle this? Well, logically we must see if we have that database table or not before we create that table. We simply write here create table, if not exists. Let's run again and see if we have. we don't have the error. Now it's time to add data. We add data in the same way that we've been adding using the command line. Okay, we know that we have to execute that statement, so it's statement that execute and write the statement. We're going to insert data. We have to just write insert into our table name, which is contacts. Here we pass the parameters, name, we're going to insert phone, email, close. I'm going to pass this line to the next one so that we can improve the readability of this code. So Control Enter, you can see I'm going to continue adding the information right here on the line 16. Values, the first one is going to be Faraday. His name is Faraday, phone number is this one, and the email is going to be faraday@somewhere.com. okay, close the parenthesis and semicolon right here. Let's run and see if we have any error. It's running. Okay, we don't have. Let's see if our data was saved in our database. Open our DB browser here, open database. I'm going to copy the path where this program is currently in, and I'm going to pass it here for quick. Okay, select the database, open, and here we have the schema. Let's browse data. We have our data here, Faraday, this is the phone number, and this is the email. Okay, now I want you to know that depending on the database you use and the connection type you use, something you have to explicitly do is to commit any change you make to your database in order to those change persist in your database. If you don't commit, closing the connection will make the change become lost. Well, here in the JDBC connection, the default working way of it is to commit all changes automatically. So if you make any change, it's going to commit to the database automatically and you won't lose any data. Let's change this connection to don't automatically commit to our database. Come out here and say connection.set out commit to false. And now let's add a little bit of data here. I'm just going to copy this line, or you can simply click the combination Ctrl D and it's going to duplicate. Here I have. I'm going to say this one is Einstein. His phone is going to be this one, and here we have Einstein@somewhere.com, and here we have Newton. Here we have also Newton. Now let's run this program and see what is going to happen. Okay, let's come here and refresh. We don't have any data added here. We just have Faraday, which was the last data we added before we set the autocommit to become false. That's happening. What is happening right here? Now we set autocommit to become false, and we're not committing any change that we make to our database. That's why these additions are not being reflected in our database. We can commit by ourselves any change that we make, and we're going to see this later on. So right now we're just going to remove this that set this information right here, statement connection that set out commit to become false, and leave it. I just wanted you to know that it's going to out commit for us. Let's come here and update. Here we have Faraday, Einstein, Newton. Okay, we've added Faraday 2 times. No problem, that's not a problem for us. Now let's just make these lines be ignored by our JVM. Okay, now that we know how to make the addition of data, it's time to learn how to update. Well, it won't be harmful because you know how to do that. Simply write the same commands, statement that execute, and here we're going to say update what? Contacts, and set, we're going to change the phone or the email. Okay, we're going to change the email, it's an option. Set email to be equal to instant to here.com. okay, where clause, don't forget, name is equal to Einstein. Okay, let's just semicolon and see if it's going to happen. Run it. Cool, no exceptions. Let's see here. Until now we have Einstein's email being equal to einstein@somewhere.com. You can read here. Let's update and see if it changes to einstein2@here.com. Okay, we have einstein2@here.com. Simply. Let's comment and just delete a record. We're going to say statement that execute delete from our table contacts where, okay, I'm just going to get rid of who. I'm going to remove where name is equal to Newton. Let's see. Now run. Okay, no problem. Let's update here, or you can simply click F5. Okay, we don't have Newton in our database table. Now let's learn how to query some data here in our program. Not querying that data from the DB browser, but here in our Java application using JDBC. I've commented that, and let's just click Ctrl S to save our program. When we query the data with the statement that execute, what happens is that it's going to return true if the statement we execute returns an instance of the results of the class, and it's going to return for us false if returns an update count or no results, because sometimes we can have this type of situation. So let's write here statement that execute and select all from our table. Just write select all from our table contacts. Cool. And we need to know that when we query our database, the method returns record matching all the queries. As a result, set instance. Okay, so we have to create a result set and call it. Let me just import. I'm going to hover it and import that class result set and call this result set being equal to the statement that get result set. So we select with our statement and we take the result from our statement and put it on a result set instance. Okay, now while our result set has records or result set that next, in other words, what are we going to do? We're going to print those results in our console. So system out that print line, and we're going to say result set that get string, and here we're going to pass the column that corresponds to that field that we want. So every time it has a next element, that means it has all that row. So we're going to take the values corresponding to the columns that we want and print out in our console. Result set that gets string. Let's pass the field. The first field is going to be the name. Then we're going to just give a space dash. Okay, plus I'm just going to copy this, come to a new line and ask results, okay, that get string. All I want here is the font. Do the same, come out here, and what I want now is what happened here. Okay, now I want to add the email. I should put this parenthesis right here. I'm going to put result set that get his email. Cool. Let's see if everything is fine here. Cool. I'm just going to indent a bit this code to this part. Put this on the next line. Okay, now all we have to do is come here and close the resource result set. So we come here, say result set that close, and run this program. Faraday, his phone and email. Faraday, phone, email, Einstein, phone, email. Okay, don't worry about having this duplicate data. It's not a good idea to have duplicate data, and we're going to get rid of that. A mini challenge to you right now is drop this table, add data, and print to the console right now. To drop that table is simply, all you have to do is come here. After you try to create or not, in a new line, come out here and just write statement that execute what's happening, drop table, and write the table name. Is going to be contacts. Okay, let's run. Okay, now let's come here to our DB update. We don't have any data. Now I'm not just going to drop it, I'm going to eliminate because I just wanted to solve that with you. Come here, eliminate these comments, just save it and run again. It's running and you're going to see this data being reflected in our table. Okay, here we have also, let's just comment this line because we don't want to execute them every time. And now let's simply update. We've updated. We can come here and confirm also. Cool. Let's just comment these two lines. I want to talk to you about what's going on here. While results set that next, it's going to print for us this information. I want you to hover on this method next. It moves the cursor forward one row from its current position. A result set cursor is initially positioned before the first row. So the first time you call this method next, it makes the first row the current row. The second call makes the second row, and so on. I want you to know, when a call to the next method returns false, the cursor is positioned after the last row. That's why you have false here, and false is not equal to true, then you don't have to print nothing because you've looped through all the records. Come here on result set and check what it has for you. This is just a table of data representing a database result, which is usually generated by executing a statement that queries the database. Hover on execute. It's just to execute a given statement in SQL. You can see that working with IntelliJ or an integrated development environment facilitates your life, because you can read what the objects that you are creating or the methods that you are using do behind the scenes. And here we are just closing this resource of result set. And it's important to know what happens here. Get result set retrieves the current results as a result object. This method should be called only once per result. If you have a result here that is being retrieved after you execute this query, you should call this get result only once if you are querying using the same statement object. That's it. If you call more than once, that new result is going to override the current result that exists. That may not be the case that you want to use in your queries or your program. You may want to use different queries for different purposes at the same time. In this situation, you have to create different statement objects. But if you want to use the same, what you have to do is get the result, use that result, make another query, use the result, and so on. So this is the end of the class. Revise in case of need, and let's move to the next lesson. We're going to see the method that execute query. Without further ado, let's go to our code environment. What if I told you that there's an easier way to perform query? Instead of using that execute as we are doing here on line 23, we can use the that execute query on line 24. Let me comment this and just come here and say that execute query and pass all that, select all from contacts statement here, and here we have less code. So first create a connection here to our database, then we create a statement object from the connection. Next we create a result set by calling the that execute query method of the statement object, and this method accepts the select statement that we have written right here. Next, what we do is just look through the results that are packed to our result set instance with the name result set, and we're using the next method to continue to loop until we have rows to loop. Then we are just printing results here using the methods from the result set object. Get string. If we had different data types, you could say that get double, get int, and so on. And finally, we just close the resource. Let's run and see if we have the same output. We have. That's it. This is the end of the class. Please revise in case of need, and let's move to the next lesson. We're back to the SQL Database with Java course, and today we're going to talk about constants and method. Let's come here to our code, and the first thing that I'm going to do is to drop the table if it exists before I execute something here related to the creation of the table. So statement that execute, okay, I'm going to drop table if exists, and the table name is contacts. I'm just going to remove these comments right here, leave the update, remove this statement because I won't need anymore. Let me run again, open the DB browser here, go to the path where our program is, but before, let's wait. Okay, we have the results. So now we can go to our DB browser, open the database, paste the path where this is. Okay, select, and here we have browse data. Cool. Let's just close. I just wanted to see if everything was right there. You can see that we are using hard-coded strings for SQL statements here. We are saying every time that we make an insertion, name, the telephone, the email, we have all these get connection string URL here written by ourselves in a hard-coded way. We have also here repetitive code, and it's hard-coded at the same time. Using hard-coded string for SQL statement is not seen as a good practice. I'm going to give you an example that is going to illustrate why this is not a good practice. Okay, imagine if we are here working with our application and we want to update this column font to be mobile underscore font, like this, mobile underscore font. Well, if we want to update, we would have to change that string in all places we use it in our program. And do you know how many times we've used it? We use it once here. Okay, it's one time, 2, 3, 4. Okay, just count how many times we've used it. And in large scale applications, you may use more than tens of times. That may be overwhelming for you because you would have to change in every place. And we can accidentally just update the wrong place. In addition, our application becomes vulnerable to SQL injection attacks. Instead of just repeating these strings in different places, we are going to use constants. Constants are values that will not change during the execution of our program. And you may know a constant in your life. For example, from math, pi is 3.14, 15, and so on. Take that analogy and put into code. Pi value doesn't change. The value of these columns also, they don't change. And if you want to change, well, you will have to change ounce, and it will not change during the execution. And if you change for one place, you would have to change to all the places. So let's just make them constants. Let's come up here right after we create our main class and start adding this public static final string, and this is going to be the database name. It's a constant, db underscore name, which is equal to, what is the database name for us? The database name is my first db in java.db, this one. Let's just copy, come here and put between quotes my first db in java.db. Okay, semicolon. A shortcut to write public static final string, PSFS. Here we have, just write the name. And we have next what? The connection string. Okay, so let's say connection string. This is going to be equal to all the string that I have here. So I'm just going to copy. Let's copy this string, okay, until this point. I'm going to cut, instead of copying, is this one, plus what? Our database name, which is the DB name. So this is our connection string. If we change the database name, it's going to be reflected right here in our connection string. Okay, next what we have? We have our table name, which is this one, contacts. Let's PSFS and say this is the table contacts. You can give any name that you feel comfortable, and I'm using uppercase letters because it's a convention in Java to use uppercase letters when we declare a final value or a constant, in other words. And the name is contacts. Cool. PSFS, what we have now, our column, and the column is first the name. So we're going to say column name is equal to name. Control duplicate, duplicate. Here we don't have the column name. Instead of name, we have the column representing the font, and the value is phone. Next we have what? The email. The column is going to be email. Cool. Until now. What we have to do now is just substitute what is hard coded by the strings that we have created here. Connection string is our connection string here. The URL of the connection string is connection string, which is the concatenation of this string here, JDBC, SQLite, and so on, concatenated with our database name here. Next, let's see what we have to edit. Okay, drop table if exists. What table? Is the contacts table. Let's remove this and just write plus contacts table, which is tables, not table underscore contacts. Hit enter. Cool. Next we have here create table if not exists. Okay, contacts. We can change this to be what? Contacts. Instead of hard coding here, we're going to say plus what is contacts is the table contacts that we have created right there. Plus, let's move to the next line in order to improve the readability. Okay, let's just start removing some information here. All of this and add new information. We know that the statement is create space table space if not exists is space the table name, and what comes next is the parenthesis being opened, then we pass the column names and the data types. So we just need to add plus. Next we have the string space open parenthesis. Okay, plus what we have here is the column, and the column is going to be this one first because it's the name. Its data type is text, then we have a comma, space, plus we have the next column name, which is the font, plus, and we have here next what? The data type is an integer. I've written correctly, hope, yes. Plus I'm going to move to the next line in order to improve just readability. Column email, plus space, the data type is a text. Okay, plus close the parentheses. Okay, and here we've written all our first statement. Cool. We have here what else? We have the statements being created here in line 22 with 23, 24, and so on. These statements are responsible for the insertion. Cool. We can also improve the way that it's written these statements right here. Okay, let's say insert into, let's say plus here table contacts, plus let's remove these contacts that we have here. But before we do so, I'm just going to create all that statement here in order to preserve these values. I don't want to remove them right now. I'm going to say statement that execute insert into space plus table contacts, open this parenthesis. Okay, next let's add the column name, which is column underscore name. Okay, first quotes, we have to put a comma, space, next line, just to improve readability. The next column is going to be column, this one, phone, plus, let's go to the next line, which is going to be column, email, and here we have what we need to do right now. Just a plus sign, come here and close this bracket. Simply created the same structure that we have here, but using the constants. So insert into contacts, as we have here table contacts is this one, contacts, open parentheses. If you don't want to leave the space, you can. Okay, just put it here, remove that white space, plus this is the column name, which is name, and we have what? This comma, space, the column font, plus this comma, space, email, plus, okay, we are closing the parentheses. Cool, until now. Let's just come here and put this character. We have basically this first part. We need to concatenate with this second part, which is taking the values. Right now, what we have to do is simply continue to write our commands. So we concatenate and say values. What are the values? Okay, open parentheses. Concatenate with what? Now we have a name. What is the name that comes first? The name that comes first is Faraday. Then we have the phone number and we have the email address. We can simply just put here Faraday, then put his data. I'm just going to copy. What happened? Oh no, failures. I should concatenate here. Let's close the parentheses, close these codes. Now what we can do is simply create a comment to this one. Come here into code, block level, and run to see if we have any error until this point. We don't have, so our development process is working fine until now. Let's just copy this line, copy it, paste how many times we have Einstein, Newton, 2, 3, and just change the values here. The next one that we want to save record is for Einstein. His number is this one, his email is this one. Okay, so I'm just going to copy this info and paste here. Comment these statements also, log level, execute and see if we get any error. No, we don't get. Now let's talk about these two guys. Update, simply change this to the contacts table, contacts, okay, plus, and we have here the string set. The column is email, so set plus column email plus where is equal to this one, Einstein to here.com, okay, plus where we should eliminate this because it's where we have this written column name. Okay, the column name is equal to what? Einstein. Let me just back. Okay, what's happening? My computer is slowing down, not responding. I'm going to pause. Okay, I do have now is equal to Einstein. Okay, let's see if we have any error. Run again and delete from. My computer is slowing down. Hope something went wrong where Einstein. Okay, there is a syntax error right here. Of course we have. Let's run and come here, delete from, plus this is the table contacts where we leave it here, where what, now we have the this column name okay, is equal to Newton, and it's fine. Let's see if everything is working right now. Something went wrong. Okay, near from contacts, what's the error syntax right here? Can you figure out? I figure it out. We need to have a space here. Run again and see what we have. Okay, everything working fine. So we can now remove this. Now we have to do the same here. Let's just change from space plus table contacts. Here, instead of having name, this is just column name. This is the column phone. This is the column email. Okay, run again lastly, and we have everything working fine until now. And now it's time to talk about another thing. You can see that we are repeating code, and this should be easy for us. We can't repeat code. That's not a good practice. We have the ability to do that, but it's not a good practice. We're going to use methods to solve this kind of situation. So let's create a method right here, a private. It's a static one, no return type, and this is responsible for making the insertion of contacts. It's going to take a statement object, is going to take a string that's going to represent the name, integer value to represent the phone, and string to represent the email. Okay, cool. What we have to do here is simply copy one of these statements that are responsible for making the insertion of data for us. Copy this one, insert into, come here, column values. Okay, Einstein. Okay, now what we have to do is come up here and just change this stuff. Instead of coming here and writing the statement that execute insert into, we just call that method. So we say insert contacts. The first guy is Faraday. What is, okay, I'm just going to copy. I don't have time to write. This phone number is that one, and his email is this one. Cool. Don't forget to pass the statement object first. Very well. Let's just duplicate these values and come here, copy. The next one is Einstein. Put here Einstein. We need to change these single quotes to be double quotes. Here we have. Also here we have. After Einstein we have Newton. I'm just going to paste here Newton. Let's just eliminate this, run this code and see if we have any error. No. Do you see what happened here in our project? We have removed the hard-coded SQL statements, and now we have reduced the duplicated code. This is not the best way to remove that duplicated code or to insert contacts in our database, but for now this is good. During these lectures you're going to see more advanced ways to do this. This is the end of the class. Please revise in case of need, and let's move to the next lesson.